Alright, so we're looking at some balancing problems here. These are hydrocarbon balancing problems specifically. We've got C2h10 plus O2 gives CO2 plus H2O, and always with these hydrocarbon combustion problems, the products will always be CO2 and H2O regardless. Now it's just a matter of doing the balancing part. And what I like to do is first of all balance the carbons. I've got two carbons here, so I'll put a 2 in front of a CO2. Now the carbons are balanced. Always balance the oxygens last because you've got one here, you've got one here, and one here. So look at the hydrogens next. We've got four hydrogens here, so we've got 2 here, so I'll put a 2 in front of here. Now we've got a total of 4, so we're good there. Now let's look at the oxygens. We've got 2 times 2 is 4 here, and we've got 2 here. That's a total of 6. Now I can balance the oxygens just by putting a 3 in front of here like this, so that's 3 O2s. And just in case you don't believe me, 3 O2s will give a total of 6 oxygens there. And we've got 2 CO2s here. And then we've got 2 waters. And you can see that gives us 1, 2, 3, 4, 5, 6. So a total of 6 oxygens on that side, 6 oxygens on this side. Everything else is balanced okay. For more details about this, take a look at my video tutorial on balancing combustion reactions. Alright, so that's for that one. That's number 11. Alright, let's take a look at the next one. This is number 12. C4h10 plus O2 give CO2 plus H2O. Let's see, we've got 6 carbons here. I'll put a 6 in front of this one. I've got 8 hydrogens here, so I'll put a 4 in front of here. Now we've got 8 on this side. Now let's look at the oxygens. We've got 6 times 2 is 12, plus 4 times 1 is 4, so that would be a total of 16 oxygens on this side. Now I'll put an 8 in front of here and I'll be good. So that's a total of 16. Let's count this up and make sure we've got everything here. We've got 6 carbons, that's good. We've got 8 hydrogens, that's good. We've got 16 here. We've got 6 times 12 plus 4 is 16. So everything is balanced on that one as well. Alright, let's take a look at the next one, C4h10. Now I already know that this one's going to be a bit more involved than the ones I've already done, because what's going to happen here is when I take this number here, the 14, and I divide it by 2, I'm going to get an odd number. In the previous examples, when I took the number of hydrogens I had and divided by 2, I got an even number. So this would be 2, this one would be 4, but now I do this one, I'm going to get 7. Now what that means is I'm going to have to do something else in order to make the oxygens work out, and you'll see how that goes in a second. First thing I'll do, I'll balance out the carbons. I've got 7 carbons here, 7 carbons here. I've got 14 here, so that means I'll put a 7 in front of here. Now that gives me 14. Now let's look at the oxygens. I've got a total of 14 here plus 7, that's 21. So I've got 21 oxygens over there. Now in order to make this balance out, the only thing I can do is put a 21 over 2 here in front of the O2. I want you to take a look at my video tutorial on balancing combustion equations for more proof about what I'm doing here, but that's in essence how I'm working this out. I've got 7 times 2 is 14 plus 7 is 21. 21 over 2 times 2 is also going to be 21. That's how I'm getting the 21 oxygens on this side. The last step I have to do here is to make sure all of these are whole numbers, and the way I'll do that is to multiply everything here by 2. So that's going to make it 2 C4h10 plus 21 O2, and that's going to be 14 CO2 plus 14 H2O. Now I'll just double check and make sure everything's okay here. 2 times 7 is 14, that's 14 carbons, that's good. 2 times 14 is 28, 14 times 2 is 28. Over here we've got 21 times 2, that's 42 oxygens. Over here we've got 28, 14 times 2 is 28, plus 14, which is also 42. So you can see that one is now completely balanced. Alright, let's look at the next one, C4h10 plus O2. And again, I see I'm going to run into the same problem as I had with the previous one. And I know this because when I take the 10 divided by 2, I'm going to get an odd number. Alright, let's see how this works out. I'll put a 4 in front of a C to balance the carbons. I've got 10 hydrogens here, so I'll put a 5 in front of the water. That's okay. Over here I've got 4 times 2 is 8, plus 5 is 13 oxygens. So I'll go over here and I'll balance that by putting a 13 over 2 in front of that. 13 over 2 times 2 equals 13. So that is now balanced. But to finish this off, I'm going to have to go ahead and multiply everything out by 2. So it's 2 C4H10 plus 13 O2 will give 8 CO2 plus 10 H2O. And now you can see that this is all balanced. We've got 2 times 4 is 8 on the carbons. We've got 2 times 10 is 20 on the hydrogens. 10 times 2 is 20. Oxygens, 26. 13 times 2 is 26. 8 times 2 is 16. Plus 10 is 26. So everything does still work out with this one as well. Alright, let's take a look at the last one now. We've got C6H6 plus O2 gives CO2 plus H2O. Again, I want you to see that by taking the number of hydrogens here, 6 dividing by 2, I get 3. That's an odd number. So I know I'm going to run into the same issue as I had with these two here, 13 and 14. So what I'm going to do here is I'm going to take 6 C's, and that's put a 6 in front of CO2. Then I've got hydrogens. I've got 6 here, means I put a 3 in front of the H2O. So now we've got to look at the oxygens. That's 6 times 2 is 12, plus 3 is 15. So we've got 15 oxygens on this side, and that means I'll put a 15 over 2 in front of this one, and 15 over 2 times 2 equals 15. So now the oxygens are balanced, but we can't have fractions in here, so we'll multiply everything by 2. So 2C6H6 plus 15 O2, 12 CO2, and 6H2O. Let's make sure everything's balanced out. 2 times 6 is 12. 12, that's good. Hydrogens, 2 times 6 is 12. 6 times 2 is 12, that's okay. Oxygens, 15 times 2 is 30. Here we've got 12 times 2 is 24, plus 6 is 30. So everything balances out here as well.